All right. What's up, everybody, and welcome to another episode of Model Monday Live, where we challenge you to take a 2D drawing, turn it into a 3D CAD model as quickly as possible using any 3D CAD system. And it's so good to see all of our regular friends in here. Hello, one and all. Let me get the technical side of this all working correctly, but I gotta tell you, it was an awesome weekend, guys. One of my favorite weekends of the year. We got to do Pinewood Derby this weekend with the pack. Got to see all the kids working so hard to build their cars, or at least watching their dads work so hard to build their cars, and then racing them down the track. And it was very special. This year we did a blacklight themed Pinewood Derby, which made it a little bit unique, a little bit different from how we've done it in the past. And the kids all painted their cars with blacklight paint, and it was just really, really cool. I mentioned that to you guys because we might do some cool special contests here at some point. Actually, I don't want to say too much. I don't want to overpromise and underdeliver. I want to do the opposite, right? But what's up, everybody? I hope you guys all had a great weekend. D. Vicky Chong is in the chat, holding it down in her admin mod role. She's on the injured reserve list right now. We're trying to get her back into the mix. What's up, Jern? Welcome. What's up, Mr. Mesa? Says, what's up, y'all? Happy Monday from Mr. Mesa's third period welding class. Yo, nice. Serial Sal is in the chat. Says, hi, everyone. What's up, my friend? Mr. Mesa is here. Says, where's Toby? I'm here, my friend. Victor and chat. Hello, Victor and chat. That's from TooTall. Oh, that's from me. I wrote that. Tom is here in the chat. What's up? Someone you don't know is here in the chat. FPV Kev is here in the chat. Larry is here in the chat. What's up, my friend? Teach A6 is here in the chat. And, of course, Rock Crawler is here in the chat. Matab is here in the chat as well. Dom says you got to keep expectations low. They're already high. Yeah, exactly. We're just going to keep going. We just got to keep going up nonstop. Well, guys, I got some coffee here, some delicious coffee. It's Groundhog's Day here in the United States, which means that we use a groundhog, which is a type of animal. I guess I don't know what class they're from. Is a groundhog just like is it considered a type of rodent? I feel bad saying that he's a rodent. You guys let me know in the chat what type of animal a groundhog is. But basically, there's an animal, a land dweller, looks kind of like a badger, and he comes out. Serial Sass is Big Rat. Okay. All right, good. I'm not alone. He comes out here in Pennsylvania, and he lets us know whether or not it's going to continue to be cold for 6 more weeks, or whether we're going to get an early spring, whether the weather is going to break early. And I am not making this up, guys. This isn't a bit. If you're from a different country, you're probably wondering, what the heck is this guy talking about? But this is what we call Groundhog's Day, February 2nd. And unfortunately, or fortunately, depending on what you prefer, he predicted it's going to be cold for 6 more weeks. So there you go, guys. I hope you guys enjoyed that explanation. That's a big news. There's a lot of big news coming out of the United States, and this is the biggest of all the news. Jern says great movie as well. Yes, fantastic movie. And if you guys haven't had a chance to see the movie, I encourage you to watch it. But I just was thinking this morning as I was anxiously awaiting the results of Puxatony Phil, what other people from other countries think about our method of predicting the weather. I think it's probably very, very strange to them that this is what we've settled on here in 2026. But look, guys, this is where we are. So, Serial South says the groundhog, also known as the woodchuck, is a rodent. All right, so it is a rodent. Good to know. All right, guys, welcome. Guys will use, you get called Darren, says, you guys will use rodents, but you won't use a metric system. That's it. You got it. We figured it out. That's exactly it, my friend. That is exactly it. You nailed it. And Uncle Facepound is here. Serial South says, that's right, IPS for life. That's what's up. All right, guys, listen, we're going to get into it here. This is going to be a special episode of Model Monday Live. Today is actually a day when a lot of SolidWorks users are at a world conference for SolidWorks. So we're going to be doing a bunch of Onshape modeling today. So if you like Onshape, you are in the right place. And if you get sick of me doing Onshape, then we can switch back to SolidWorks for the last one. We're actually going to do 3 speed modeling challenges today instead of 2. We're going to mix it up a little bit. So we're going to move along here pretty quick. And I'm going to solve some of these with you, and I'm going to do them sort of tutorial style, but I'm going to solve these at a pretty fast clip today because we got 3 rather than 2. So if you guys have ever been interested in seeing how I model in 3D CAD, this will be a chance for you guys to see me going close to regular speed We'll see. We'll still throttle it a little bit, but we'll go close to regular speed. Belonging to the ground squirrel family. I like that we're actually learning a little bit about this. Don't be mad at us. We have culture at Gold Darren. Yeah, there you go. That's what that. I like that, Dom. That's right. It's just culture. It's just a culture thing. All right, guys, we're going to be doing 3 CAD speed modeling challenges. Thank you all so much. Thank you to the amazing members of the TooTallToby community. We really couldn't have all the cool stuff that we have without all of you. If you're not on the Discord yet, be sure to take a moment and join the Discord. We would love to see you on there. It's always fun to interact and chat with everybody on the Discord. It's fun to hear your feedback. One of my favorite things about the Discord is that a lot of times people are willing to post videos and tutorials of themselves solving some of the challenges, and it's really cool to see the way that people think through these challenges. So check out the Discord if you haven't been there before. All right, and today we're going to do 3 live solves using Onshape. I'll do some SolidWorks if you guys really want it, but you just got to make some noise in the chat and let me know. Otherwise, it'll be SolidWorks or it'll be Onshape. One thing to mention here about the points, we're just going to do points for the first 2 challenges. So we'll do the first 2 challenges kind of similar to how we normally do them. But for the 3rd challenge, we're not going to do points. That one's just going to be exhibition. But you can still compete and you can still earn points over on the TooTallToby website just for fun. You can earn a completion point. The Discord, you can go to TooTallToby.com. It's up in the pull-down menus at the top under resources. TooTallToby.com, just go to the resources up at the top, and there's a link to the Discord in there. Error 1. What's up, Error 1? Error 1-1. Very nice to see you in here. And XLECHU, Jlishu says, hello. Welcome. Guys, don't forget to hit the like button, share, and reshare, subscribe. I'm looking at my monitoring system up here to see if my mouse is dying for this system. All right, good. We got almost 40 people in here. Let's go. Thank you guys for joining me today. I know there's some other live streams going on now. We're competing against some other live streams. Maybe you're watching both. But here we go. Let's get into it. Today's challenges, what we're going to be doing is we're going to be showing all of you a 2D drawing, and we're going to be challenging you to turn that 2D drawing into a 3D model as quickly as possible. You're going to try to calculate the mass and then enter the mass directly into the YouTube chat. Now, in the first half of the show, we'll use YouTube. In the second half of the show, we're going to use the app over at TooTallToby.com, and that's how you can earn your point in the second half of the show. And what do you get if you answer, or sorry, in order to answer correctly, you need to calculate the mass correctly. In order to calculate the mass correctly, you need to have the correct material density. So if you go to TooTallToby.com/materials, or if you go to the flyout menu at the top under resources, you can go to materials FAQ, and then what you'll see that we've got all the information about these materials, as well as some resources as to how you can set these up in your CAD system. So this is TooTallToby.com. This is the live website here, resources, materials, FAQs, and you can see here all the different materials that we have, as well as resources to set these up in your CAD system. So you can go through and you can set these up yourself, and that way you'll be able to quickly use the materials in your CAD system. For today, if you don't have them set up, then you can just manually input the density. A question came in the chat from Hassan, says, your calendar's empty. I'll fill it out today. Yeah, thank you. Good reminder. We're not doing nothing this month. We're actually doing a lot this month. So we'll get the stuff filled out here for all of you. And the basic rules are you can use any 3D CAD package. Make sure you answer with the specified precision. First answer correct in the chat wins. I'm going to do this one with you. What do you win? You win a point on our Model Monday Live leaderboard. I think that one's actually maybe not up to date. Let me go here to the Model Monday Live one. Let's see here. 2-2-2-2. Yeah, it's the same. It actually is the same people, but it's Dom. Dom's got 3 points. Congratulations, Dom. Mr. Misa, 3 points. Matab has 1 point, and Gray has 1 point. You can see last year, our first place finishers, we got co-champions from last year, both got 19 points. So it's really anybody's game still. We're only in January right now, and usually we have 8 points available each month. So be on the lookout for those points. Good luck winning those points. We'll have a special prize at the end of the year for whoever wins the Model Monday Live World Championship 2026. All right, guys, here we go. The advanced rules is meant to be fun and good-spirited. Occasionally, I will make mistakes. I'll miss a dimension or something on the drawing. If that occurs, we'll just do an audible. And the Ivan exploit is permitted in these challenges, unless it's noted that it's not permitted, but it's usually not noted. And with that, we are going to move into the first challenge. As soon as I show this challenge on the screen, grab a screen capture, and you can try to model this and see how fast you are against these chat pros. We got 44 people watching. If you enjoy these types of challenges, take one quick moment and hit the like button, and then get your print screen button ready, because here we go. This first CAD challenge begins in 3, 2, 1, go. What is the mass of this part in XXXXX grams? Wow. This part's in millimeters. The material's plain carbon steel. The density is 7,800 kilograms per cubic meter. And the complexity is a tier 6 complexity. Of course, we're going to be using some of the models from the tournament today, a little bit remixed. We remix these things a little bit as we bring them into the world of Model Monday Live and the TooTallToby practice models library. So, guys, good luck with this model. And I'm actually going to solve this right along with you. We're going to see if you guys can beat the sensei. Okay, let's see if anybody can beat the sensei in these challenges. So good luck to everybody. I'm just going to give you another minute here to properly capture that model, to properly capture that. Usually what you want to do is you want to use like a screen capture tool, like window snipping tool, or I used to use this tool called MW Snap. That was pretty good tool. So you guys can use whatever tool you want, but you can see here that we're looking at drawing number 26-02-02, and that drawing is called Lantern. And thank you so much to Uncle Facepound coming in with some super chat, getting the ball rolling here, getting the train rolling. Silhouette 1646 says, I love Fusion. Haha. Yo, Fusion, welcome here. You guys can use any 3D CAD system. You can use anything you want. So it's up to you what you want to do. We had a Fusion champion last year, 2 years ago, 2024, technically 2 years ago. And we had a Fusion champion, world champion of 3D CAD speed modeling. So Fusion, welcome. I do some Fusion videos. I actually just made a Fusion video this weekend. So I got to get some Fusion action in there. It's pretty fun. And guys, I'm just going through and getting something ready here. A little bit of stalling. Stall. And good luck to everybody on this challenge. This is not an easy one. I see the chat went a little bit quiet. Not an easy one. Let's see here. All right, guys. Well, with that, we're going to jump into a live solve. That's it. Let's go. Let's live solve this bad boy. So you can see here that we posted this model here in Model Monday Live, and you can answer this model directly in the chat whenever you finish it. But what I'm going to do now is I'm going to try to solve this thing for all of you live, and in person right here using Onshape. So while everybody in the chat is trying to solve this thing, I'm going to jump into Onshape, and I'm going to create this model here. I'm going to attempt to create this model. Wait a second. I think I already have this up, right? Hold on. I'm trying to open this, and I already have it. Yeah, I'm good. We're good. I think I'm just going to solve this right on the website. That's right. You heard me correct, everybody. We've already posted this one on the website. We're showing it to you here in Model Monday Live, and we've already posted it over on the website. So if you want to immediately get a completion point for this model, you can solve it in Model Monday Live, but you could also solve it over here on the website. It's the same drawing, same answer. So once you get it in Model Monday Live, you can also enter in your answer over here on the website. Here we can see TooTallToby.com is the website. You can sign up totally for free. And when you sign up for free, what you're able to do is you're able to utilize the library of 2D to 3D CAD challenges. So you can see all these 2D to 3D CAD challenges that we've got here. There's over 280 challenges at this point, I think. I think we just crossed over 280, right? 289, wow. We're closing in on 300. So what you can do here is you can go to TooTallToby.com, and then up at the top, if you have a free account, you can access these challenges up here, the featured challenges. This month, the featured challenges, or this week, the featured challenges are sponsored by some upcoming SolidWorks training that we've got. So if you want to check out some sweet SolidWorks training, you can check it out here. But you can see here that the challenge is called 26-02-02. Click here to practice. And here we go. Guys, look, nobody's done this yet because I just posted it. Nobody's had a chance to do this one yet. So here we go. Click here to begin. And my name's Toby. I'm using Onshape. I'm from the United States. And 3, 2, 1, go. So what the question here is, what is the mass of this part in XXXXX grams? And we're going to type that in over here. 1, 2, 3, 4, 5 grams. Nope, that's not correct. I always like to fire in a guess there just to kind of see if I can maybe get it right just by guessing. So the question here is, what is the mass of this part in XXXXX? I don't know, 5 place precision. And let's get into it here. So anytime I go to create a model in 3D CAD, the first thing that I do is I start out by kind of asking myself, what is my game plan for this model? And I think that in the case of this model, I'm going to discretize this model. Now, when I say discretize, what I mean is I'm going to break up the model into a few different sections. So I think that the first section that I'm going to break up this model into is going to be this lower section down here. There's like a hex and then another hex. And then I've got, so down here, got like a hex and then another hex. And then I've got this upper section. I've got a hex here and a hex up here. And then I've got a blend between those two. So that's going to be a loft. So I think those kind of jump out at me as immediately being solvable and being solvable pretty easily. After I've got those sections done, then what I can do is I can start to attack this section here. And you can see that that cage area has been isolated for clarity to make it a little bit easier to understand what's going on with this model. So the cage area has been isolated for clarity. I'm going to go through this cage area here and I'm going to try to model that up and come up with the correct mass of that cage area, which it's kind of an interesting shape there. I think what I'll do is I'll extrude that and then I'll shell it, and then I'm going to punch these windows through. And then finally, I'm going to finish up with this upper area. I would call this upper area the revolved areas. So we've got this revolved sphere here, and then we've got this revolved ring here. Call that the revolved area. One thing that you'll notice here is that there's a call out here that says window cuts are 90 degrees from the angled face. And then you can also see we've got this thing called an auxiliary view here helping to illustrate the window cuts. So you can see here that when we're looking in on those window cuts, we're really looking dead on at those windows cut. There's no angle or anything when we're looking in on those. And then that's confirmed up here in the section view that those are coming dead on, from right here. We got a 90-degree angle. So basically what that's saying is that we create the sketch here on this surface, and then we'll do an offset entities, offset here, offset these entities to get that 6 millimeters for that window shape. Finally, we notice here that when this thing is being extruded, it's going to be extruded with 8 degrees worth of draft. So that's something else that we want to think about as we get into that part of the design. So that is our game plan. You can see here that in the app, we've got an icon on the app here. Oh, whoops, did I just close the whole app? I think I did. All right, guys, we're starting over with the app. You can see here that we've got an icon on the app here. I thought I closed out of my, just my window for that, but I think I closed out of the whole thing, so that's all right. We already have the, now, Matab, you can get the point here by entering in the chat. Yep, you can get the point here by entering directly into the chat. So I'm going to say, click here to begin. Oh, man. You know what happened? One of the guys, if you're watching and you submitted your time and you came in super fast with your time, can you do me a favor and just go into your this is a little bit of a technical, it's a glitch. I should have thought about this when I set up the challenge, and I'll fix it for the other challenges. But can you just go into your My Analytics, and then when you go into My Analytics, just go down here into that run and delete that run. Like whatever run you just did, if you finish that run and the time is like 1 second or 2 seconds or anything under like 15 seconds, can you just go in there, please, and delete that? And then that'll fix the issue. It's my bad. I should have, the way I created the challenge, I should have done the challenge a little bit differently. But whoever's in there doing this, whoever came in with that first answer, if you don't mind, just go in and fix that, and that'll fix the issue for me. Sorry, guys, a little bit of a website bug here. You can still solve it obviously using this version of the print. Yeah, I screwed up. I made the solve time to the. I mean, it doesn't matter. It's something that's happening in the background. There's a technical thing that I could have made a different decision, and that would not have happened. I would have prevented that, and I just made a bad decision. Let's see here. That non-sec should resolve once somebody clear your thing. So if you're watching, guys, if you went in here and you solved this thing, you can enter it in the chat. Yep, Darren. If you're watching, you went in and solved this thing, to just go in here and go to My Analytics, and then you can find that super fast run and delete it. Whoever did that run super fast. Otherwise, I'll just have to clean it up. To clean it up myself later after the live stream. This challenge will just be kind of dead for this duration of the live stream. All right, I'll come back and I'll look at that a little bit later. We already have the drawing here, and so I'll use that drawing to perform this Onshape live solve. So welcome everybody to this Onshape live solve. I know we just went through and we did the. TZ says I can't go into analytics, doesn't load. Great. Let's see here. It looks like it's loading. Maybe just give it a minute. Maybe you solved so many that it's just taken forever to load. All right, so I think we might know who it was, so that's good. We'll figure it out, guys. Don't worry, it's all good. We'll figure it out, and while we're figuring it out, we're just gonna solve it here. Just let me know, Neem, once you get that deleted. I'll keep an eye on the chat, and then we'll figure it all out. It's all good. It's all good, guys. It's Monday. It's Groundhog's Day. This is it. We're going to just do it again. That's what Groundhog's Day is all about. All right, guys, welcome to today's live solve using Onshape. We're going to try to go through this in just a few minutes because we are running up against the clock. We're trying to do 3 challenges today for the chat, and we want to make sure that we get these all done. So let's do this first one here. A moment ago, we went through and we came up with a game plan for this challenge. This challenge here is a tier 6 challenge. It's called the Lantern, and what our game plan is we're going to start out down here with these hex shapes. So we're going to create this hex shape down here, this hex shape down here. And then once we create those hex shapes on the bottom, we're going to create the hex shapes that are a little bit further up on this model. So we're going to create the hex shapes that are up here, this hex shape and this hex shape, then we're going to loft those together. Then we're going to focus on creating this kind of frame area. We call this the cage area. And then we're going to finish off by creating these kind of revolved areas up top. And we talked about this in a little bit more detail just a few moments ago, but I just wanted to review that because I think it's always good to come up with a game plan before you actually jump into the 3D modeling. Now that we've got that game plan, let's move this over here and we're going to go into Onshape. And I'm going to choose to create this document in the public space. So if you ever are looking for this document, you can find it. In the public space by searching this text string. I'm going to say create public document, and this is a model in millimeters, so you want to make sure that you're working with the correct unit system. So you can see here that we've got our hamburger menu, workspace units, millimeters, so we're good there. Top plane, S key, begin a sketch, N key to get normal to. S key, I'm going to jump into my polygon tool, single click here on the origin, move my mouse, single click, let go of my mouse, enter for the number of sides, and then that first hex is going to be at 150. It's kind of like the outer hex on the bottom. Single click here, move my mouse, single click again, enter to get the number of sides, and then I'm going to type in that second one, 115. That's the next one that's down there. Enter, and then what I could do is I could do one more hex down here, single click, move my mouse, single click, let go of my mouse, enter, and this one's going to have a hex size of 100. So that gets me that 115, that 150, 115, and 100 that are down at the bottom. I think I'm going to save these guys up here for a second sketch. So now that I've got those hexes in place, the last thing I need to do is just come in here to Onshape, hit escape, pick this line H, pick this line H, pick this line H, S key, extrude, and this extrude's going to go to a depth of 12, but it's not going to be the entire sketch here. I'm going to press the space bar, and then I'm going to come in here and I'm going to choose this guy, and this guy, get all 3 of them. They're going to come up to a height of 12. Once I'm done with that extrusion, I'm going to show the sketch again, because I want to use that sketch a second time. So S key, extrude. Now, again, here I can press the space bar, and that way I can just choose these regions. And then for the height of that second one, I'm going to say that's going to go to 12, but it's going to start with a starting offset to an entity of this face here. So that gives me those first 2 hexes down at the bottom. Now for the hexes up top, I'm going to create a new sketch plane. So I'm going to click this plane here, S key, plane, and then the height of that plane is going to be at 150 from the base. Okay, so that's this dimension right here, 150 from that base. And so now that I've got that that location there, S key, begin to sketch, N key to get normal to, S key, polygon, single left click, move my mouse, single left click, let go of my mouse, and then I'm going to press enter for 6. Whoops. Enter for 6, and then I'm going to type in the hex there, which is going to be 165. That's a larger one. Single left click, move my mouse, single left click, let go of my mouse, enter for 6, And then for that smaller hex that's up top, that's going to be 50. Hit escape, click this line, H key for horizontal, H key for horizontal, S key extrude. And now this one's going to come up to a height of 12. And again, I'm going to make sure that I include that inner hex as well. And now I'm going to take that sketch and show it again. And I'm going to maybe click in this region here. You can pre-select as well, S key extrude. And now this one is going to go to a height of 12, but I'm going to go down here to starting offset. And the starting offset here is going to be at 52 plus 12. And that way I get that hex that's up top there that is at 50 hex, it's 12 millimeters high. And so what this did was it set me up now to create the loft here, because when we're creating a loft, we can loft from a face to a face and blend those two together, and that's going to be an add so that it merges in with this body and this body. I'll click on those bodies and I'll merge those all together, and there we go. That creates that loft. Now, that not only sets me up with that upper region of the model, but it also sets me up to do my extrude from this third and final hex that I've got down here in this original sketch. So I can again choose that kind of inner region, S key extrude. This extrude is going to start from an offset at an entity, which is going to be this face here. And then this extrude is going to go up to an entity. So it'll go up to face, up to this face here. And then this extrude is going to have some draft. So down here, we got this option for draft, and we're going to have 8 degrees of draft on that extrusion. I'm going to do this as a new body because that way I can hide these original bodies and really focus in on this new body. So in this new body, what I'm going to do is I'm going to shell this body here, and I'm going to say that's going to shell to a wall thickness of 7 millimeters. And then once I've got that shell there at that wall thickness of 7 millimeters, I'm going to pick this face here, which is on the front of the model, begin a new sketch, and jump into the offset command. And then I'll pick that entire face. And this is the cool thing in Onshape. When you offset, you can just pick the entire face. So I'll reverse the direction so it's going the right way. Left click to accept the direction. And then the offset distance is going to be 6, enter, and then S key, extrude. And this is going to be a remove. And I'll probably just dump this out to like 12 millimeters, just a little bit beyond whatever the wall thickness is of the shell. Now, this is where it gets kind of interesting because now I'm going to create a circular pattern of that feature. And so what I need is some kind of an axis coming up through the middle of the part. And I figured that at this point, if I'm already going to be creating an axis for that circular pattern, I may as well incorporate some of these dimensions so that I can reuse that axis when it comes to creating these features. So I'm going to create a line to use for the axis of the circular pattern. I'm going to create it on the right plane. S key, begin a sketch, S key, line. I'm going to start down here at the origin with that line and create a line that comes up here from the origin. Going to make sure that it's vertical, and I'm going to type in that height of 257, and then I'm going to create another line here that comes up a little bit further, and then I'll just add a dimension to that line as well and give that a dimension of 290. So I'm capturing these two dimensions down here, this 257 and this 290, because I know I need an axis to revolve about anyway. I may as well just use that same axis for this layout sketch. Now, I know you Onshape guys are going to say, you know, instead of revolving about a line, you could revolve about a mate connector, and that's fine. I could do that as well. I'm sure that that's a solution as well. Basically, anytime I do anything in Onshape, I get a comment in the YouTube comments, which I love. I absolutely love getting these comments. Don't get me wrong. It makes me smile every time. But I get a reminder that a lot of times I go the long way around because I'm not a master yet at working with mate connectors. So I love getting that feedback, and please keep it coming because I'm going to start working those mate connector shortcuts into my workflows. But for now, I'm going to stick with the old way, and I'm going to say circular pattern, and I'm going to say features to pattern. The feature, I'll pick on a face here of the feature. The axis of the pattern will be this axis here. 6 instances for that pattern, and there we go, a feature pattern. Make sure you remember when you're doing that pattern, you have to come up here and fly out this menu, and that way you can choose feature pattern. And then also as a shortcut, remember, you can click on a face or a face of the feature here. You don't have to pick it from the tree. Okay, now we can show these other two bodies. These other two bodies are now looking good. We can actually take all this stuff and combine it together. So what I'm doing is I'm picking all the parts here in the parts list, and then I'm doing a right-click Boolean union check mark. Okay, and there we go. There we've got all those. Be careful when you do that. If you choose the option for keep tools, then you get kind of like a doubled result. You get an extra body here that's doubled up on all those existing bodies. So when you do that Boolean, make sure you don't choose keep tools. That way you don't get that extra body over top of all the existing bodies. And now I can show that sketch again that I used for the layout, and I can go to the right plane again, begin a sketch, orient my view, and I can create a circle here, right here, dead on at that at the center point of that sphere, and that circle is going to have a diameter of 25, and it looks like This is telling me that I did something wrong, because that obviously is not correct for the location of this revolve. So let's figure out what we're doing wrong here. Let's get this circle kind of locked in here. And let me, don't want this to be midpoint here. I could drop it up here. I'll just revolve this since I'm already in here. But obviously I did something wrong here. So axis of revolution will be this guy here. There we go. There is our sphere shape. And let's go back to that sketch and take a look at it. Whoops, go back to this sketch and take a look at it. So we have our 257, 290, so that all looks good. So it must be something a little bit earlier with my offsets. Looks like the cage area is a little bit too short. I suspect that's where I went wrong. So this sketch here, this is at 150. Should be 150, not from the top plane, but 150 from this face here. That's the mistake that I made. Okay, so not from the top plane, 150 from that face there. There we go. There we go. There we go. Everything resolved. And then for this revolve, I would say I want that to be an add instead of a new, and merge with all to merge that into the rest of the body. One final feature here. We'll go right plane, begin a sketch, get normal 2. That's the N key to get normal 2. Single click here, create a construction line. Single click up here above this thing and make that a diameter of 7. Make sure that that has a dimension that goes from the outside of that arc to the center line and then cross over the center line. That's our 65 OD. And now we can turn that into a revolve. And there we go. That should be pretty close. P to hide our plane, Shift P to hide all of our construction geometry. You can right click here and go to edit appearance. The customers always like it when you edit the appearance. And then we can assign the material. So right click here on the name of the part. We can say assign material. And this is going to use a material from the TTT materials library. There's a custom materials library, and I'll include a link in the highlight video on how to get this material. And this is plain carbon steel. And we hit the green check mark, and 10478. I'm going to go with 10478. Let's go. Let's go. We did it. Congratulations, us. We did it. And so that is how you can solve that model using Onshape. If you guys enjoyed that challenge, be sure to hit the like button. Be sure to let me know down in the comments if you liked that one. But that is how you can solve that thing using Onshape. Kind of blast through it at a pretty good clip. And let's get back into the presentation here and see who earns the first point for today. As always, guys, please like and subscribe. Please tell at least one coworker about the channel. And, of course, please be on the lookout for our training site. You can visit us, TooTallToby.com/training. And we've got some exciting SolidWorks training coming up. I know I just did an Onshape demo, but we do have some exciting SolidWorks training coming up. And, oh, hey, guys, look, it looks like we got it fixed. Thank you so much to the production team for working in the background and getting that fixed. It is fixed now, so you can now go to the site and you can actually log in here. Now, before you submit your answer, maybe let the timer run out like 20 seconds or so, because if you answer too quickly, then your time won't show up on the leaderboard. I'll fix that as well in just a moment, but you can see here that if you let this run out for a little bit, then you can confirm that you got the correct time, and you can get your first point on the leaderboard. So 10478 and enter, and yes, we did it. It's going to kind of mess up the analytics here a little bit, but thank you guys. Thank you to whomever went in and fixed it. Thank you to the production team, and I will fix that as well in just a moment. And guys, please be on the lookout for our training. We do have some really exciting training coming up, and we're excited to host that for you, and we're excited for you to do that training. Okay, and with that, let's continue on here. I want to keep things moving along pretty quickly here. Don't forget to visit us at TooTallToby.com. We can participate in TooTallToby.com in the second half of the show. But for this one, for the first half of the show, to determine who gets the point here, we're going to look through the chat. Let's bring up the chat here a little bit larger so everybody can see it. And we're going to see here that the first person to come up with the correct answer was it Dom? Let's see here. Was it Gray? Nope, we're still going up here. Looks like it was Matab. 10478. Congratulations to Matab getting that right. Well done, my friend. Well done. And so Matab's going to earn the first point in our Model Monday Live leaderboard. Congratulations to anybody who got it correct. Normally, we're a little bit more ceremonious, but today's a special episode. We're going to go at a little bit of a faster speed here today. So congratulations to Matab. And with that, we're going to move into our second challenge. That is not the correct answer. Here we go. In this second challenge begins in 3, 2, 1. Go! And so we can see here that this one is the fireplace grate. And we also just posted this on the TooTallToby website. So for this one, if you want to earn the point, you got to do it over on the TooTallToby website. You got to answer over there on the TooTallToby website, and ideally you can start the challenge over there as well. The challenge is up and running on the TooTallToby website. So if you visit us at TooTallToby.com, you click here to access the full library. You can see here that in the full library, we now have 26-02-03, and you can say click here to practice, and you can give this thing a try directly on the website. So give it a try. We do have it posted here as well in the live stream. Oh, I didn't show my screen there. Sorry. And Harry coming in with the Buy Me a Seltzer Water membership. Thank you, my friend. Thank you. We're going to have some special content going up this week for our members. So thank you so much for joining. I actually just cracked open a seltzer water while you were doing that. So thank you. And guys, I showed this, but I wasn't showing my screen. TooTallToby.com, access full library. And here you can see that at the same time as I released the drawing on Model Monday Live, I also released the drawing here on the website. So you guys can give this thing a try directly on the website. You can answer on the website. And thank you, Harry, for the membership. Welcome to the channel. And Gold Darren in the chat says, damn, I'm getting flashbacks. Yeah, these were some of the ones that Darren had to do. So let's see if we can solve this one in Onshape. We're going to do an Onshape live solve here. Welcome, everybody, to Model Monday Live. We're doing a special episode where we are speed running these models. And today we are going to attempt to solve a model from the TooTallToby website. So you can visit us at TooTallToby.com. You can see here that we've got a library of over 280 challenges. I think this is actually challenge number 290. So quite a few challenges here, which means that it's really helpful when you're able to sort through these. You could say, I'm just a beginner, so I want to do some tier 1 challenges or some tier 2 challenges or some tier 3 challenges. Well, today we're going to try to do a tier 5 challenge here, one of the more difficult challenges in the library. And this challenge is called 26-02-03. Here we go. We're going to solve this thing in Onshape. So we can see here on the challenge dashboard, so far, no one has completed this model. Let's see if we can be the first one to complete this model. Click here to begin. Got my username, my CAD system, my country, and go. And so the question here is, what is the mass of this part? And the significant digits here are XXXX grams. Looks like this part is made out of 6061 aluminum. And this is definitely a tricky part. You know, you look at this part, you think, should I do it as an assembly? Should I do it as a multi-body part? I think I'm going to do this as a multi-body part. And I think that what makes this part tricky is that these components here are shown down here, and it's the crossbars, you know, these crossbars down here in 6 places. This is the common geometry, but the crossbars are all slightly different because of these angles here, because of this 10 degree, 20 degree, 30 degree angle here for each of the crossbars. So whenever we're looking at a 3D CAD model, whenever we're going from 2D to 3D, whenever we're imagining a model, we always want to ask ourselves the same basic questions. First of all, where should the origin be located in this part? And I think that in the case of this model, because we've got centerline symmetry here, and we've got kind of like a pattern from the front to the back, I'll probably locate the origin either right here at the very front or maybe even right here in the middle. I might just decide to locate it right there in the middle. And then the next question you want to ask yourself is, what is the very first sketch going to look like? Well, for me, I think that the easiest geometry to visualize is this geometry here on the front of the part, because I can just draw that up following the dimensions that are shown here kind of in this front view. So I'm going to draw up those legs using the geometry of the front view. I'll probably just model half of this thing and mirror it all at the end. So I'll draw one half of one of these legs. Then I think I'll do a pattern of that leg to get me that back region. And then after that, I think I'm going to start approaching this more tricky geometry here, these things. I think what I'm going to do is I'm just going to draw it from the top. You know, when you've got a dimension here, I'm going to click this open in a new window so we can zoom in a little bit more on this upper section here. When you've got a call out like this, like all rear points touch this line, and you've got the same call out in the front. And then also when you've got this dimension going right to this corner, this dimension going to this corner, this dimension going to this corner, instead of imagining this as a curved bar, I'm just going to imagine it as a rectangle on an angle looking down from the top. And I think that's going to make it a lot easier for me to visualize what's going on with that geometry. And so I think what I'm going to do is I'm going to make those 3 rectangles in the top view, extrude them to the max height, and then I'm basically going to use those as like blanks that are going to give me reference points that I can use for the sketch of this shape here. I'm going to sketch that shape on, and then I'm going to use that sketch to kind of cut away the geometry. So sounds good in the form of a plan, but let's actually put that plan into action here. I just think even though it took me 2 minutes and 40 seconds to come up with that plan, I think it's always good to come up with a game plan before you actually get into the 3D CAD. And if you agree, be sure to hit the like button on this video. And so I'm going to move the timer over here so we can keep an eye on the timer. I'm going to bring up my keyboard cam, and let's jump into Onshape and give this thing a try. So here in Onshape, I'm going to close the current document. We just solved that one a moment ago. Create document 26-02-03 space fireplace grate 1. And I'm going to save this into the Onshape public space, which means if you're an Onshape user, you can just search for that text string in the public space. And even if you're not an Onshape user, you could just sign up for a free account and then search the public space, and then you could look up this document. So even if you're using a different CAD system, if you just wanted to poke around in Onshape and poke around in this feature tree, just sign up for a free account, and then you can search that syntax. So now let's follow our game plan. We already know we're in millimeters because that's our default units. So hamburger menu, units, millimeters, good. Front plane S key, begin a sketch, N key to get normal 2. S key, create a line, single click here at the origin, move our mouse up, single click, and that's gonna go up to a height of 90. We're gonna move our mouse over in this direction to get to our first leg, and that's gonna come over at a distance of 150, which is 300 divided by 2. We're gonna come straight down here to a horizontal with the origin, come over, auto dimension there at 20 millimeters. We're gonna come back up here. Notice how I'm not picking up on the horizontal relationship. Sometimes you just have to kind of wake up this point. Just put your mouse over it, and then you can get that relationship. Single click there, move over in this direction, single click, come back, touch the end point so I can come off with an auto radius. Single click, and that radius is going to be 35, and then come down at an angle with tangency, and we'll come down to about this point, and then draw one final line that just kind of comes straight over. The angle on that bent area there is 110, and you can see here that we were able to more or less get this thing kind of fully constrained here just using some of those workflows. I'm going to hit escape here, and I'm going to take this line and press Q to make it for construction, and then I'm going to use a window here to select all these lines, and then I'm going to use the offset entities command to offset those lines. Actually, you know what? That's a misstep. Let me hit escape. I'm not going to do that. I'm just going to offset these 3. So I'm just going to take these 3 and offset them. So window, these lines here, offset, and that's the correct direction. And then that offset distance is going to be 20 because all these bars are 20 by 20. Now I can hit escape. I can drag this end point down, S key trim. I can trim off this end here. And then I can hit escape again, and I can drag this point over. And then just click on that point, click on this point here, V for vertical, S key line. Dragging a line here. Here, I'm going to get rid of this 150 because I want to match the customer's design intent. So I'm just going to click on that 150, press delete, S key dimension, and create a dimension that goes to the construction line so that I can get the doubled dimension of 300. And then finally, I'll get the max dimension here, construction line. This should fully define the sketch, and it does. The sketch all goes back black. Excuse me, that's what we want. And so the sketch is all nice and black, nice and fully constrained, and we are ready to move on with this thing. So now S key extrude, and what we're gonna do here is we're gonna say we want this to start at an offset, and we want that offset to be 160. We want that to be that 320 over 2. So that's this dimension here, 320 over 2, and that way our origin is just right here in the middle. It's kind of arbitrary. It doesn't really matter if it's there or here. I'm just putting it there because it might pay off later, like when I go to position this thing in the fireplace. So it doesn't really matter, honestly. It could also be right in the front for this one. So now I've got that first body extruded and in the correct location, and now I can use the linear pattern command here in Onshape, and I can say I want to make a pattern of that body. For the direction, I can pick this edge here, and then the distance is going to be, let's see here, 340. So there's a little hint here. You know, when you're doing a pattern, you want to go from a corresponding point to a corresponding point. So although the gap in between them is 320, the pattern distance should really be 340. Now, the cool thing is in Onshape, after you create that pattern, you can click this face, and click this face. And then you can look down here in the status bar and confirm what the distance is between them. So parallel distance is 315. That's supposed to be 320. So I did something wrong there. I already made a mistake in this model. So let's see here. What was my pattern? Pattern was 340. That's good. What was my extrude? Extrude depth, 25. So that should be 20. So there you go. That's where you can see that it does pay off to kind of use some of these tricks to check your work as you're going instead of waiting until the very end and realizing you made a misstep. And the reason that's significant is because the location of these angled beams that are going across here, those locations are based on where this leg is and where this leg is. Okay, so if those are in the wrong spot, then your location for your angled legs is going to be incorrect as well. So now that we've got that in the correct spot, let's go on. Let's create the next feature in our design. And we talked about how this next feature in the design, we're basically just going to create a rectangular prism here that represents the key layout dimensions that we need for each of these crossbars here. So we're just going to create a rectangular prism looking down from the top view. Now, the height of that, the max height of that is a max height of 220. So we could create a reference point up there, but I think in this case, if we don't merge them, we could just have that extrusion come all the way up from the bottom. In other words, we can have the extrusion come up from the bottom all the way up to 220. I'm going to give that a try. We'll see if it works. If it doesn't work, we can adjust our strategy. So here we're going to go top plane, S key, begin a sketch, N key to get normal to, and we're going to create a special type of rectangle here, an aligned rectangle. Okay, and so we're going to single left click, single left click, single left click, hit escape, S key. We're going to create a dimension here, and we're going to give that a dimension of 20 millimeters. 20 millimeters for that rectangle, kind of get it sized close to correct here. And then you can just window that rectangle, Control C, click somewhere else, Control V, click somewhere else, Control V, and you can see that you can locate this rectangle in that new spot. We can just drag it around. Okay, kind of drag it around here. We still got to add in the relationship to that line at 80 millimeters. So let's add in that next. So we'll create a line here across the top. We'll make that line construction. Okay, and we can create a line here across the bottom as well. I don't need this one. I just was already in a chain. And then we'll create that 80 there. Create that 80 there. Oops, I got a double dimension. Little misclick again. Just slow down. Just going to slow down about 10%. Still going to go fast, but I'm just going to slow down about 10% because slow is smooth and smooth is fast. All right, and now we could just add in some relationships. Relationship here, I. Relationship here, I, relationship here, I, relationship down here, the frontmost point, I, relationship here, the frontmost point, I, relationship here, the frontmost point, I. And then we just need to add in our dimensions. So we jump into the dimension command, and the dimension is going to be to that same point, in this case, the more left point there, and that's going to be at 90 millimeters. To that same point, it's going to be that kind of left point. That's going to be at 250. Again, doubled across that center line in the middle. And then this final dimension here, 400 to that same point. And then for the angle, I don't know of a way to get the doubled angle in Onshape. So for this one, you just have to do the math. Or you could type in 10/2 if you wanted to do 10 over 2. For this one here, you could do 20 over 2. And then for this one here, you could do 30 over 2. I mean, I don't want to brag or anything, but I could actually probably do that in my head. But it's still good to let Onshape kind of double check your math for you. So now that I've got those three shapes in place, I can do an extrusion, S key extrude, and this is going to be new, and this is going to go up to the max height there of 220. So new, creating these three new bodies here. And now I can begin sketching that next shape. So I could pick this face here, S key, begin a sketch, N key to get normal to, S key to create a line. And I can create a line here that comes down, goes at a radius here. I can make this the inside radius, 25. Comes across here, horizontal. It should really be tangent, and then I'll add horizontal later. Come back this way, inside radius of 25, and then comes up at an angle here again at tangent. And then this relationship should be to the top line, not to the side. This relationship here should be to the top line. And then I can take that geometry, add in the horizontal relationship here on the lower line, add in the angle here of 100 degrees. Add in the angle here of 100 degrees. And then I can take those lines and I can offset them. So just like we did earlier, I can take that geometry and I can offset it. Here, I'll click on the arrow to go the right direction, and that's going to get offset to 20 millimeters. Now I can finish this thing off just by adding in that perpendicular line. So we'll create a line here that's perpendicular. Okay, and maybe to be safe, you can make sure that this is perpendicular to, I mean, no, it will be because the other ones are offset. So that's good. Trim that off. And then we'll do another one over here, perpendicular. So I begin the line, kind of like wake up this line here, and then get that relationship of perpendicular. Okay, and then I can trim those off as well. And now I can add a relationship here of coincident and a relationship here of coincident and a relationship over here of coincident, and that fully defines that sketch. And then I can take that geometry and S key extrude, and I can say I want to remove. And the cool thing is in Onshape, you can pick up on these regions to extrude. So I can say I want to cut extrude this region here, this region here, this region here, and this little region up here. So in Onshape, you can let it pick up on those regions for you. And so when you're done, I think I'm going to be left with the shape that I want. So I'll say that's going to go through all, and it's only going to affect this part here. And oh yeah, that looks good. And so then what I could do is I could you could also use the intersect tab. Yep, we like that. We like that. Then what I could do, I'm just reading the chat. Saw the chat come in there from someone you don't know. And so then what I can do is I can go here to this sketch that I used to create that geometry, right mouse button, copy sketch, click on this face here, right mouse button, paste sketch, right mouse button, paste sketch, okay, and then click on this face here, right mouse button, paste sketch. Okay, just make sure you click in the background first so nothing is selected. So what that does for me is it sets me up now where I could jump into that next sketch, and all I need to do is here, I, here, I, here, I, and here, I, and here, I, fully constrained, S key, extrude, remove, through all, and I'll come out here and say I want to use this region, this region, this region, and this region up here. And now, one more time, roll forward here, go to this sketch here, click here, I, click here, I, click here, I, click here, I, and click here, I. So copying that paste and reusing it is really the trick there. And then S key, extrude, remove, through all, and I'm going to say that I want it to affect this region, this region, this region, and this region here. And then for the merge scope, just make sure you pick this body here for that merge scope. So hit the green check mark, and there we go. We now have half of the model. Hopefully all our dimensions are correct. And then what I usually will do at this point is I'll take these two bodies and mirror just those two bodies. And for the mirror plane, I can pick this face here. And that way I can do an add and I can merge those together. But I don't want to like merge everything together. So that's why I do them as two separate mirrors. So then I can pick these three and I can mirror them. And then for the mirror plane, I can just pick the right plane here and mirror them across as well and keep them separate. Of course, you could merge them all together, but in manufacturing, they're probably going to be built separately. So then we could right click here and we could say assign material. The trick that I'm using here, the shortcut I'm using is a shift key. So I pick the first body, hold shift, pick the last body, let go of shift, right click, assign material for 8 parts. And that material is going to be this 6061 aluminum. So again, this is coming from the Onshape custom TTT custom library, and it's going to be the 6061 aluminum. And we hit the green check mark, and now with those bodies already selected, I can come down here into the corner and click this mass button, and we can see here that we're coming up with a mass of 6635 grams. So let's head back into the TooTallToby app, and 6635 grams, and oh yeah, we did it. We got it correct. 16 minutes and 2 seconds. Very nice, very nice. And so in the first half of the show, we saw that it was Matab who answered correctly. He was the first person to answer, and he answered in the chat. In the second half of the show, we used the app here at TooTallToby.com because it makes it fun. It makes it kind of cool to have it be interactive with all of you. And what we do is instead of using the top 100, because the top 100, it might show some ridiculous times, like this is 13 seconds. Well, what Gold Darren probably did is he saw the drawing on the live stream, and then you just work from the drawing, and that's fine. A lot of times what people do is they look at the drawing and then they work from that all day, kind of off and on, and then they come back and they refresh the website, and then they enter their time, and their times are very short. So what we do here is we set ourselves up so that even though Gold Darren answered in 13 seconds, we track the amount of time that has elapsed since the challenge was released, and we do that here on the first 42 leaderboard. So the point for this challenge is going to go to the first person listed here on the first 42 leaderboard. Let's take a look here at the first 42 leaderboard, and look at this. He's on an absolute tear. Mr. Misa from Poland running Fusion, absolutely crushing it lately on the Model Monday Live leaderboard. Comes in with a time of 6 minutes and 20 seconds from the time it was released. We released this drawing at 1:37 p.m. and Mr. Misa finished it by 1:44 p.m. Wow, that is impressive. Followed closely by CSWE Victor. Very nice, very nice. Matab here, finishing it 9 minutes and 48 seconds after it was released. We got B Dayton here, finished it 14 minutes and 0 seconds. We got H11R rocking free CAD. That's what we like to see. Indonesia, 14 minutes, very nice. We got T Lust from France running Fusion, 15 minutes. We got Gold Darren here, 16 minutes, and then bringing up the caboose here, TooTallToby finishing this challenge in 19 minutes, 29 seconds from the time it was released. So, guys, thank you so much. It's been a really fun time seeing you here in the live stream. Congratulations to anybody who finished it. That is not easy, but our points today are going to go to Matab and also going to go to Mr. Misa, and we are going to do the we are going to do a third and final challenge here today, but I just wanted to, I know that not everybody can stick around for the third and final challenge, so I just wanted to take a moment and say thank you all so much for tuning in today. I hope you guys did enjoy the live stream. If you're here for the first time, I hope you guys enjoy these types of challenges. We are going to do another challenge for all of you, and we are going to answer once again on the website. So if you don't have an account yet, please go to the website, TooTallToby.com. You can sign up for a free account, but if you do have to leave, I understand, and don't worry, we will be here for you again next week. We'll have more challenges next week. And of course, please visit us at TooTallToby.com. You can access our library of over 290 of these challenges, and you can play along with, you can challenge yourself, you can see if you can get better over time. That's what really makes these challenges fun. So thank you guys so much for joining us, and we're going to continue here with the third and final challenge. We're going to kind of go into bonus time, but just in case you have to leave, I just wanted to again say thank you for joining us. We are going to be back again next week. Be sure to check out the website. Be sure to check out the training. Guys, the training is coming up on the 10th. So if you're interested in some advanced SolidWorks training, make sure you sign up for that before the 10th. It is coming up pretty soon here. Okay, so thank you guys so much. Congratulations to the winners of the points. We're not going to do any more points. But we're just going to do an exhibition here. We're going to do one more as an exhibition. So it's such a fun way to start the week. I hope you guys are enjoying it. I haven't really had a chance to read through the chat, so I'm going to take a second and read through the chat as well here. Let me just get one thing set up here real quick. Harry says, please, bro, press 11 in the browser. He doesn't like seeing the web address up top. All right, I'll make it a little bit bigger this time. All right, guys, we're almost ready here. This one is... And... I don't think I have a preview of this one. So this one we're just going to have to do on the website live. Okay, so this will be a fun one. It'll just be pure live on the website. All right, so I'm going to get ready to release this one. Let me just get my final setup here for this in place. I think I have everything I need here. Don't think that. Maybe that. And yes, that. And yes, that. And okay. All right, I'm going to get this ready to go, and we're going to get back into it here. And again, I just want to say thank you guys. What a fun way to start. Mr. Mesa says, This period I can actually try. It's my off period. I can actually try today. Yo, perfect. Perfect, perfect. That's awesome. We're going to look forward to seeing you in here. We are going to do one more challenge for everybody. While the production team is getting that challenge ready, we're going to just take a look at the chat real quick here. And thank you guys so much for being a part of this Model Monday Live. And here we go. The next challenge is officially live. So good luck to everybody in the chat, and we're gonna solve this thing using Onshape. So good luck to everybody. Take a look at TooTallToby.com. The final challenge is officially live. We're not gonna show you a preview here on Model Monday Live. We're gonna let you guys do it live. Give it a try. Harry says he's rocking a 15-inch VGA monitor. Yo, let's go. CRT, I hope. Then Lewis Mania came into the chat with a buy me a seltzer water. Thank you, my friend. It's always good seeing you in the chat. Always good seeing you on the live streams. And thank you so much for joining the channel. I'm actually drinking a seltzer water right now in honor of you guys. Let's see, some good discussion there of that first one. Congratulations to Matab in that first one. Congratulations to the production team in that first one. Yep, awesome. All right. Guys, good luck on this next challenge. It's on the website. It's already up there. It's in the featured models section. We'll leave those up there probably just for the day, and then we're gonna turn them off. We don't usually have more than 2 or 3 up there. Having 5 up there seems a little bit much right now. But we wanted to give you guys a chance to have some fun today. It's a special day. It's Groundhog's Day. Wrong side of the middle prong. Yikes. Nice. Ricardo Jean is in here, guys. We haven't made the official announcement, but if you were in the live stream on Friday, Ricardo Jean is officially a 3-time tournament winner. So huge congratulations to Ricardo Jean. And Ricardo Jean, we're going through and doing some of the models from the tournament. Wow. So what an honor to have a 3-time world champion here with us. Wow, wow, wow. Current reigning world champion at 3D CAD speed modeling. 3-time tournament winner, excuse me, in the chat with us. Harry says, Ricardo, I watched and learned so much from you, buddy. Big thank you. Grazie mille. Very nice, very nice. Dom, you made the same mistake I did. Check your 6 bars and make sure that you have the 10-degree cut. Nice. All right, guys. Welcome, welcome. Bravo. Bravo, Ricardo. You're a legend. Yes. Yes, indeed. All right, guys. Well, listen, we're going to do one more live solve here for all of you. So let's get into today's third and final live solve, and we're going to do this using Onshape. And so we're going to head over to the website, TooTallToby.com. You can see here on the website, TooTallToby.com, you can sign up for free, and then you can access our library of 2D to 3D CAD challenges. And what a library it is. Now over 290 of these 2D to 3D CAD challenges. So you guys get quite a bit of action here from the library. What's nice is that when this library gets so deep, it can be hard to figure out what exactly it is that you want to model, but we've got filters to help you with that. So you can see here that at the top of the library, we've got these filters here, like filter by challenge level. If you're brand new to 3D CAD, you can say filter by tier 1 or tier 2. Every single one of these tier 1 and tier 2 models has a tutorial that I've created and posted right underneath the challenge. So if you get stuck on the challenges, it's always good to look at those tutorials. But if you're up for something a little bit more difficult, you could go up to like tier 5 or tier 6. And we're actually going to do one of these tier 6 challenges today. So we can see here at the bottom of the library, we added a brand new challenge here, 26-02-04. Let's click here to practice. Let's take a look. Nobody has completed this one yet, so maybe we'll be the first ones to complete this practice models challenge. Here we go. Click here to begin, and we're going to be doing this using Onshape, and we're going to reveal this challenge in 3, 2, 1, go. And so here we see we've got a coffee mug. Now, what's interesting here, I'm just going to take a step back here, is that in the very beginning of the library, a lot of times people start the library and they try this challenge here. It's one of the first challenges in the library. And a lot of times people say that this is a coffee mug, but the reality is that this is actually a cap for a trampoline. If you guys have ever seen a trampoline, a backyard trampoline, they often have those safety nets, and those safety nets hook onto these caps. And these caps sit out in the sun, and they tend to break pretty easily. And so that's what this is, the 3D printable replacement for one of those caps. So this is not a coffee mug, but instead this brand new challenge that we've just posted here, Tier 6 Challenge. I'll sort here by the newest first. Tier 6 Challenge 260204. This is an actual coffee mug. So we're going to say click here to begin and go. And so the question here is, what is the mass of this part in xxx.x grams? The tolerance is plus or minus 0.9 grams. And we're going to try to model this up today using Onshape. Now, one of the strategies you often hear me describe is the idea of discretizing our models, of breaking our models up into multiple features and multiple areas of the model and kind of attacking them one area at a time. So I think that in the case of this model here, I would attack this model in Onshape by creating a revolve of maybe this shape here, maybe a shape like this. Create a revolve of maybe this shape here. Maybe I would keep this corner here sharp, but other than that, I would probably create a revolve that looks something like that. And that's going to give me the main cup shape. Now, after I've got that main cup shape, I'll go in and I'll add a fillet here, maybe add a fillet on the inside, and then I should be good to go, and I should be ready to start attacking the more problematic part, the more challenging part of this design, which would be the handle. So I always come up with a game plan. The game plan starts with asking the same questions. What is your origin location going to be? For this model, my origin is going to be down here at the bottom of the mug, right down here, just because it's kind of like at the center of where all the action is. There's a lot of dimensions that seem to be coming from that center line, so that just makes sense to me, dropping the origin right there. And then I discretize the model into different features. First sketch is going to be on the front plane. It's going to be this shape here. Then I'm going to create some features, like maybe a fillet down here and a full round fillet across the top, and then I'm ready to jump in and start tackling the handle. The thing is, when it comes to a handle like this, you can do this using an ellipse profile and then either sweep or loft the geometry, and which one you use depends on a number of things. A lot of times you can get to the same results whether you use sweep or loft. I think in the case of this model, I'll probably do it with a loft, but we could certainly do it either way. When it comes to Onshape, you maybe will find that there's some limitations using one versus the other. So I think that might be another reason why I would use loft here if I'm doing this in Onshape. But there's other reasons why you decide to use one or the other. In this case, I am going to do it with a loft, which means I'm going to need either 2 or 3 profiles. It looks like in this version of the model on screen, it was probably created with one profile here, one profile up here, and then mirrored down. And I kind of like that approach. It would save some time, but I don't really like having that seam there. I kind of like the idea of this being a smooth transition, so I think I'm going to do it with 3 profiles. So I know I took 2.5 minutes to go through and come up with a game plan there, but I think it's always important to come up with a game plan before you start modeling in 3D CAD. And if you agree, be sure to hit the like button on this video. So I'm going to take this, I'm going to say open in a new window. And that way I can move this window over to my second screen so I can model on my second screen. I'm going to take this window, I'm going to move it over here so that we can all keep an eye on the clock as we're modeling. And then what I'm going to do is I'm going to bring up Onshape. I'm going to bring up my keyboard cam so you can see what kind of keyboard shortcuts I'm using along the way here. And we're going to start a new document. I'm going to close this document and create a new document. We'll call this 26-02-04 Hot Cocoa Mug. And if you guys want to find this model, you can just search in Onshape in the public space. If you have an Onshape account, you can access this. Or if you don't have an Onshape account, you can still access this using a free account. So here we go. Here we go. And we're going to say create public document. And I see in the chat, it looks like maybe somebody finished the model already. That's what I'm gathering from that comment there from someone you don't know. I think maybe Mr. Misa finished the model pretty quickly. So now we're going to go to the front plane. We're going to follow our game plan. S key. Oh, sorry. First thing we'll do is just double check our units. My default units are millimeters, so I know that I'm good here. But just in case you're using a different workspace units, check my units here. And then I'm going to go into... let's move this over so we can see the clock. There we go. I promised the chat that I would move this up so we'd have a little bit more room on screen here. So now we're going to go front plane, follow our game plan, front plane, begin a sketch, orient our view. And we're doing that with the letter N. So front plane, begin a sketch, orient our view with the letter N. S key, I'm going to create a line, and I'll just make this a construction line. This is going to be kind of my max height, essentially, but it's going to be my axis of revolution as well. So I'll just bring this up here like so, and then I'll create the geometry for this thing. So we'll start out with a small line here, like so. We'll give that a wall thickness of 6 millimeters. We'll come over here like so. We'll single click, move our mouse back to that endpoint, and then come down with an arc. And that arc is going to have a radius of 15 millimeters. And then we can maybe at this point hit escape and just kind of lock in some of these other dimensions. So the dimension from that endpoint to this construction line, and we double over that construction line, is 62 millimeters. And then the dimension from this line here down to the origin or down to the top plane is 4 millimeters. So sometimes I'll do that along the way when I'm creating a sketch. It's maybe a little bit more complex. I'll just kind of lock down some of the geometry as I'm going along. So now we can kind of sketch in the rest of this geometry. And I think I'm going to use just kind of flats and sharps here to get this geometry in place. I'll finish off that line there, hit escape, and just grab this point and move it down to here. And so that gives me kind of the basic shape that I'm going to be revolving. Now all I need to do is add in some additional dimensions. You'll notice here when we dimension to the center line, we can cross over it and then get the double dimension for the revolve. So for example, this vertical line here for our OD, we can cross over that center line and then put in that OD of 87. And we can then hit escape and just grab a blue point here and drag this blue point over to get these other points in line. And we can see here that we can go back into our dimension command. One little trick I like to use in Onshape, a lot of times I'll dimension directly to a plane. So you can dimension to a plane there and then come up to that point, and that's like a nice little shortcut too if you're using the top plane as your ground plane like we're doing here. We've got an angle dimension here for draft. This angle dimension is, whoops, misclick there, try that again. We've got an angle dimension here for draft. That angle dimension is 4 degrees. And then we've got a dimension here to this sharp point, and that dimension to the virtual sharps is 62. So to the virtual sharps. And it looks like we've got everything, but we still have a blue line here. So what do we do when we have a blue line, when our geometry is under constrained? We hit escape and we grab a blue point and we kind of drag it around a little bit. So then we can do S key dimension, and we realize, oh, I'm missing an angle dimension there. You drag it around to use, so you can use your engineering intuition to figure out what it is that you're missing. So we'll make that 45 degrees. And there we go. Revolve. Our revolve axis will be this line here. Boom. There is our first feature. Main mug shape. Okay, over here, Shift N, main mug shape. Now we can go to our next feature, S key fillet. And this is going to be a fillet down here at the bottom. I think this might be what Ate missed when he was doing the tournament. That fillet has a radius of 8 millimeters. And then we could do another fillet, and we don't really know what the radius of this fillet here is supposed to be. We don't know what that radius is supposed to be because it's drafted up to the top there. So when we go to the fillet command, we can use this option, full round. And this is perfect for this application because we don't know necessarily what one half of that wall is, and it might change if the draft changes or if some of those other dimensions change. So instead what we can do is we can say, I want to create a fillet where this is the inside, this is the outside, and then this face here is going to be removed. And instead of having a flat face there, we're going to replace that face with a full round, which is tangent to that flat face. That's what we call a full round fillet in Onshape. Very useful in an application like this. So we hit the green check mark and boom, there we go. So we could call that one like a top full round fillet. B. Dayton says, just so you know, you don't need that top fillet to be within tolerance. Okay, that's good to know. Yeah, the tolerancing on this one is a little bit weird because if you think about it, the way that you create a loft or a sweep is going to create a lot of variance. The way the different CAD systems solve those types of features, and also the way the different CAD systems solve those features, and also the whether you decide to do it with a sweep or a loft, whether you decide to do half and mirror it or do the whole thing. So I was kind of trying to factor in for that. It's good to know. I thought, I guess maybe we could get rid of that feature, but it's so prevalent and functional in a coffee mug. Maybe what I'll do is I'll make the wall thickness a little thicker to tighten that up, but that's good to know. Thank you for the heads up on that. Shout out to B. Dayton for letting me know that in the chat. So, all right, guys, let's continue on here. So now we're going to go to the geometry of the handle area. And so we're going to do this, like I said, we're going to do this as a loft, and we're going to do a loft with 3 profiles. So there's some basic things you want to think about when you're creating a loft. The first thing you want to think about is that whenever you create a loft, you should always be creating your guide curves first, and you should be creating your loft profiles second. So you want to get in there and create those guide curves first. The other thing you want to think about is how are the planes going to be located for the profiles. A lot of times what I'll do with a plane for a profile is I'll create it at a perpendicular to a curve. So what that means is I want to make sure that the end point of this curve is located in a way that when I do create that plane perpendicular to the curve, it also runs through this curve here. Now, you don't have to do this. You could maybe just locate the curve arbitrarily because you're doing it with an ellipse, but it is kind of a best practice or a better practice, and it'll maybe save you some heartache in future activities. So it is good to kind of do that, but you do have to be a little bit thoughtful when you create this guide curve up here and you create this guide curve down here. You know, if you create the plane perpendicular and the plane comes up short, then you're not going to be able to create the pierce to the ellipse, because we're going to get in here and we're going to create an ellipse for this profile. You're not going to be able to pierce it, and that's going to be a little bit of a problem. The other geometry here in the real world, what I would do here is I would do this with a spline. This would be a spline. Okay, you would create this shape with a spline. Doing this with lines and arcs is very cumbersome, and it's not really how you would do it. You would do it with a spline. But I wanted to create some geometry that you could follow and that you could use to validate your answer. So I did it with lines and arcs. In the real world, you would just do each of those guide curves with a spline. That's how surface modeling is, and that's how lofting and sweeping is. You do a lot of stuff with splines. So here we go. Front plane, S key, begin a sketch, get normal to, and let's get in here and create the geometry for those arcs. So a lot of times it's better to start out with an anchor point that you can reference. And so I'll do that just with a simple line here. And with that simple line, what I'll do is I'll say that I want that line to have a dimension from the middle plane here to that point of the line, and that dimension to be 72. Okay, it's this dimension here, 72 to there, and then 79 to here, and then the center of that plane is 62 over here. Okay, so 72, here we'll create a dimension that is 79, and then the location to the center of that plane is 62 from the base. And the reason that I did that was because now I've got some easy to reference geometry to create these arcs. So this first arc here is going to come up. I'll make that point horizontal in just a moment. And that arc is going to have a radius of 68. Okay, and then the second arc here is going to come across, and that arc is going to have a radius of 12. I made the inside ones black. Then this third arc is going to come across here, and that's going to have a radius of 24. So now I can take this first arc here, it's got this center point here, and I can take that center point and make it horizontal to this point here. That way it'll mirror correctly. Then I can take this second arc and this arc and press T for tangent. This third arc and the second arc, press T for tangent. And then I can start dropping in the final geometry to locate these arcs. You can do that by dragging and dropping. You can drag and drop these blue points here. That will sometimes help you kind of preview what this sketch is gonna do. Let's see here. Here we go. Onshape's being a little bit funky. Come on, get over there. Yeah, it's the preview's updating at with a little bit of a lag. I hate to say it, but it's not making this the easiest to do. Got her all tangled up there. Imagine this happening in a tournament. All right, let's try one more thing here. We'll go from this point to the tangency point on this arc. Let's get a horizontal dimension there. Sorry, we'll go from this line to the tangency point on this arc. And that's going to be 44. There we go. That pulled it down. And then we're going to go from this point to the start of this arc, and that's going to be 22. Okay, and now this is the inside one, and so do I mind if this inside one is coming a little bit further here? No, I don't really mind. I just want it to be in a position where I can, when I go to create the ellipse, I can pierce it to that location. So this overshooting here is actually a lot better than if this was like stopping right here. Okay, so I kind of do want this to overshoot a bit. And now I'm going to do the same thing with the outside arc. So begin an arc here. Maybe I'll lock this one down a little bit sooner rather than later. So I'll drop in this arc here, give this one a radius of 90. Maybe I can learn a little bit from my previous mistake. Click on this point here, make those horizontal, and then I'll kind of maybe just bring this point down a little bit. I picked up a vertical by accident. There we go. Bring that point down. And then this time I can jump into the line command, because when I come off of this with a line, I can come back and touch the end point, and then I can come off and give this thing a radius of 20. And then I can come back, touch the end point, and come off it again. And this one's going to come off with a radius of 180. Okay, and now that I've got that geometry in place, add in a couple of final dimensions. Dimension from here up to here, and that's going to be a dimension of 44. Oh, the other one is not 44. Sorry, that one's 33. There we go. And then a dimension here from this point over to here, and that's a dimension of 26. And now for this point here, again, you just want to, in your brain, you want to imagine what it's going to look like when you create a new sketch plane perpendicular. And sometimes you just have to kind of like eyeball it up. But it looks like here, if I created a sketch plane perpendicular there, it would intersect with that lower curve. And that's important because that's going to let us pierce the ellipse to that location. So now that we've got that geometry in place, we can mirror that geometry down. You don't have to, but you can make this line for construction to help facilitate this task. So we could go here to mirror. And we could say the mirror line is going to be this line here, and then the entities to mirror is going to be all these guys here. Or we could probably pre-select all that information, right? Because there's only one mirror line, so we could pre-select all that and then click mirror. See, and then it just rips it all down there. You don't have to make all those extra clicks. So I did a pre-select with a window, and there was only one center line, one construction line, so it automatically mirrored it down. So we exit that sketch, and that's going to be called Shift-N Guide Curves for Loft, Handle. Those are my guide curves. Sometimes what I'll do with these sketches in Onshape is I'll right-click and I'll go Edit Sketch Appearance, and then I'll change the appearance to something that really pops out because that makes it easier to pick up on those references when you're doing things like adding planes or adding in the pierce constraints. And so now what I can do is I can go top plane and then S key plane. Actually, I'll do this. I'll do top plane, and then I'll pick this point here, S key plane, and that creates a new plane at a point. So all I have to do is press Enter. And then I could pick this curve here and the endpoint of this curve. So pick a curve, pick an endpoint of a curve, S key plane, and that automatically creates a new plane using the curve point condition. And then I can click on this curve here, click on this endpoint, S key plane, and that automatically creates a new plane using the curve point as soon as I press Enter. So instead of having to go through the menu and choose what type of plane, you can just do it that way. Now, when you're lofting and sweeping, you often have a lot of profiles and planes to manage, so it becomes even more important to rename these things. So Shift N, Control C, Control V, call that one top profile plane, and then Shift N, Control C, Control V, we'll call this one bottom profile plane. And now we're coming down the home stretch. We go to the middle profile plane, S key, begin a sketch. Here under the circle command, we can choose ellipse, and then we can create an ellipse here like so. A lot of times what I'll do is I'll create a point here on the ellipse and just kind of like link it to the existing elliptical point here. Link it to the existing elliptical point here. It just gives me it just kind of gives me like an explicit point with a relationship there to the ellipse point. And I find that makes it a little bit easier to align that ellipse. And now I can click on that point and click on this curve and then pierce, which is Shift G. Pierce is Shift G. And what pierce does is wherever this red line is coming through the sketch plane, it moves that point to that location. So I'm going to do the same thing here. I'm going to take this point and move it to this location where the red line is coming through. So I can take this point here, this curve, Shift G for pierce. See, and it moves that curve over, it moves that point over to that location. And then I just need to add a dimension here for the ellipse in this direction. And that is 18 millimeters. And there we go. And then earlier today, we used the copy and paste sketch. Let's see if we can get it to work again. So right mouse button, copy sketch. We'll come up here, right mouse button, paste sketch. Let's see if this works. It kind of rotated at 90, but I don't think the ellipse really has a rotational constraint because there's no horizontal or vertical. So I wonder if I can just take this and pierce, Shift G for pierce, And then if I can just take this and like swing it down. The 18 maybe is kind of locking me in. Let me delete the 18 and then try it. It's interesting. Here, I've got a... There we go. I didn't even need to get rid of the 18. So now this point and this curve, Shift-G, pierce, and then we're going to add a dimension here on this ellipse. We'll come up in this direction, and that's going to be 18. So the handle of the coffee mug is 18 wide the entire time. You'll notice here that the guide curve is continuing on beyond. That's okay. The loft is going to start and stop at the profile. The guide curve going beyond is fine. As long as it's not stopping short. That's where we would have a problem, would be if it stops short. So we exit that sketch, and then we can do the same thing here. Right click, copy sketch, go down here to this lower plane down here. Right click, paste sketch, space bar, try it again. Wait, is that the right plane? That's not what we want. We want this one, bottom. Right click, paste sketch. Okay, and now we can go into that sketch and add in those pierce constraints. Pick this point, pick this curve, Shift G. Pick this point, pick this curve, Shift G. And look at that, nice and fully constrained. That's what we like. And now we are ready to loft those profiles. So this one here, this would be called middle profile. This one would be called top profile. This one here would be called bottom profile. And we do have that option as well to change the color of those. When you get into a lot of like heavy sweeping and lofting, this is important, changing the sketch appearance. This, for today's example, this wouldn't matter as much, but when you get into a lot of this, it's really important. It's really valuable. Sometimes I'll color all my profiles one color, and I'll color all my guide curves a different color. So this is where it's really, really important to get in there and rename that type of geometry. So now you can see that we are going to take this and use the loft command, and we're going to loft from one of these elliptical sketches. One of these elliptical sketches here is going to be a solid loft to the next. Now, because that sketch is inside of that body, you may hide that body first, and then you can pick the sketch a little more easily, and then you can pick this sketch here, and then you can pick this sketch here. One of the things that we often run into when we're lofting is if you don't pick the sketches in a corresponding location, you get this twisting. However, once you get into guide curves, so down here, guides and continuity, you can resolve this pretty easily, because once the guide curve kicks in, then it will automatically connect the profiles at the correct locations. So for example, this first profile is connecting here at like we'll call that like 1 o'clock on the clock face, and then the second one is connecting like way down here at like 6 o'clock. So it ends up doing this weird twisting thing. Well, once I use this guide curve, I'm going to have these all connecting at the same location. So it'll connect at 12 o'clock, connect at 12 o'clock, connect at 12 o'clock. Like it'll connect in all three locations at the same spot. So let's see if that works. So a little trick here for the guide curves is if you're using multiple sketch entities, you typically will pick on the first entity, and then if you pick on the second entity, Onshape thinks that that's a different guide curve. It put it into like a different category here. So I'll cancel out of that, and instead I'll expand this menu here, and then I can click into this box and add entities to that first guide curve. So once I get down to this last one down here, we should start to see a preview, and we do. So now instead of that thing just lofting from here, down, it's actually following that outer guide curve, but I'm still running into a problem where it's not following this inner guide curve here. So to get it to follow that inner guide curve, I'll minimize this first group of selections, and then I'll start picking on another entity. So I pick here. So see, now that made a second group of entities, and then I'll expand that group of entities, click in this box down here, and now I can pick on these additional entities for that second guide curve. This is really handy because it means you can define your guide curves all in one sketch, which is like really, really helpful. So now I can collapse that one as well, and wow, this is looking pretty darn good. So let's show the original body again, and let's just do this as an add. There's no need to do this as a separate body, a separate part. We can just add this in here and add it right to the same part. So we hit the green check mark, and there we go. This thing is looking good. Oh, not quite looking good, right? got this extra little dingus sticking out here. And that sometimes happens when you create geometry that goes into thin-walled parts. When you protrude into thin-walled parts with that geometry, you have to clean it up. And there's several strategies we could use to clean this up, but one that is tried and tested that we use all the time is we use what's called delete face. So if you go up here and you search your tools for delete face, this is one that you can really take a lot of advantage of. Delete, and then here you see delete face. And we use this option delete and heal. And we say we want to delete this face, and Onshape will go through and it'll clean up that little dingus. It's like a delete dingus function, and it gets rid of that problematic geometry. So we use delete face a lot, you know, not only in a scenario like that where you've got a dingus sticking through, but also in a scenario like this where maybe you received this model as an imported model and now you want to get rid of this lower cavity area here. Well, again, you could use delete face. So search tools here, recently used, delete face, and I could get rid of this face and this face. And then SolidWorks just fills in that bottom area. I didn't have to go in and make a sketch and do like an extrusion or anything like that. Yeah, and Harry says it's like cheating. Yeah, it does feel like cheating for sure. Learning how to use delete face. It's definitely a crowd favorite here at TooTallToby. So here we would rename this one. We call this one loft handle. And then we would rename this one. We'd call this like delete dingus. Dingus from handle. Loft. And then this would be main mug shape, and then we would press P to hide our planes, do kind of the final spin. I think this thing is looking pretty good. We would go here to right mouse button on the name of the part. We would go here to edit appearance so we can make it look like what the customer gave us. The customers always like it when you do that. We would right mouse button again there, and we would say assign material. And then here, this material is going to come from the TooTallToby library of materials. So I'll include a video on how to assign those materials. But this is using the TooTallToby ABS. We hit the green check mark, and then we click here on the name of the part, and we come down here to this measure mass properties. And we're coming up with a mass here of 299.4 grams. And so if we go back to the challenge at TooTallToby.com, the challenge was saying, what is the mass of this part in XXX.x grams? So 299.4 grams. So let's enter that in there. 299.4 and enter. And oh yeah, let's go. We did it. And that is the hot cocoa mug challenge there using Onshape. A really good challenge there because it teaches you about a lot of different skills. It teaches you about revolved shapes, about lofts, about sweeps, about using multiple profiles, how to set up those profiles, how to use a pierce constraint, using delete face, using full round fillet. So it's a really fun model, really fun presentation. Yeah, I wrote this. Lewis is saying he saw this in SolidWorks Live. Yeah, I wrote this presentation a long time ago, and I think it just does such a good job of teaching people some different tools that they can use when they are constructing this type of geometry. Now, one question that often comes up is, how do you know if you should do it with a sweep or do it with a loft? And one thing to consider there is, if you do have the ability to do a sweep with a guide curve, you could kind of do the same thing. You could create an ellipse shape here and then sweep it along a path here, and then you could assign a guide curve out here. But the question, the deciding factor here in your decision tree would be, do you anticipate this ellipse getting wider in the middle of the handle at any point? Because if you're working with a customer and the customer tends to change those profiles and give you that wider handle in the middle, it'll be a lot easier to implement that change with a loft than it would be to implement that change with a sweep. Because with a loft, all you need to do is find that middle profile, double click on that 18 and change it to 20, or let's make it a little bit bigger so we can really see it, make it 30. And we can see that the loft updates. But if we were going to try to do that with a sweep, the problem with doing that with a sweep is that we would have to create a 3D sketch of a guide curve out here that would pull that, because a sweep is only going to have the one profile. So you'd have to create a 3D sketch of a guide curve that would pull that sweep outward to that 30 and then tuck it back in here, back down to the 18 at the bottom. And that's going to be a lot more difficult. So that's another thing that you could use sometimes if you're like, oh, I could make this as a sweep or a loft. Which one should I use? That's kind of how you can help decide, you know, do you anticipate the middle of this thing changing? If you don't, then a lot of times it's easier to do it with a sweep and sometimes cleaner as well. Not just easier, but cleaner and easier to manage in the long run. But if you do anticipate it changing in that direction along the profiles, then you kind of have to do it with a loft. So shout out to the chat. Is ABS food safe? Good question. We only have the 4 materials. So this was OMER, Omer 8Y8 asked a question, is ABS food safe? So we only have 4 materials that we use in the TooTallToby library. You can go here to resources, materials, FAQ, and learn about the materials we use. But I would not trust ABS, especially for something that is going to be getting very hot. Ideally, we would make that out of ceramic, right? That would be the ideal material for that, would be to make it out of ceramic. I think the thing that's cool about this challenge is that, just about any time you see a coffee mug design on like a CAD repository type website, what you normally see is you see something like this. You see a mug shape, and then you'll see something maybe like this. Like if we take this plane here, EST reference geometry plane, or EST plane, excuse me, and then if I put something over here like this, let's rotate that view around a bit, and then on that plane, I'll create a shape. I'll create an ellipse here like so, kind of like what we had before. Try it again. And then I'll create a construction line. Should probably do this with a mate connector, right? And then I'll take that geometry and I'll do a revolve of that geometry. So we'll take this shape here and we'll revolve it about that line. And then we'll revolve that at, let's say, we'll do it at 180 degrees. And this is what you normally see. When you go to some CAD websites, like a CAD repository type website, a CAD modeling website, this is what you normally see from a coffee mug. And obviously it doesn't look right. And the reason why it doesn't look right is because they're typically made of ceramic and they kind of pad out this joint here because they don't want it to break. They want to give it a little bit of extra strength there. So if you're creating a coffee mug handle, you really want it to capture the essence of that if you want it to look right. Otherwise it just doesn't look right there when you do it that way. So, when you're creating a coffee mug, that's the other thing I like about this is that we really kind of help you capture that idea of, it's not a consistent profile that's simply revolved or even necessarily simply swept. It's really growing in this direction. The height of that ellipse is growing and then shrinking and then growing again as it runs around those guide curves. And to capture that type of a shape, you really need to learn how to use loft and loft with guide curves. And ellipse is a really good tool to learn how to loft and sweep with because how it does change dynamically and tends to still rebuild and also has like symmetry. It's like the perfect blend there. So with that all being said, I know this isn't for points, but just for bragging rights, let's take a look at the first 42. So here we go. Mr. Misa, once again, Mr. Misa coming in there with the correct answer. Wow, wow, wow. Very, very impressive. So Mr. Misa coming in there with the correct answer. 6 minutes and 21 seconds from the time that model was released. We released it at 2:02. He finished it at 2:09. Wow, wow, wow. Super impressive. And look at the Fusion crew here just dominating today. Fusion Onshape. That is nice. Nice. And look at it, 6 minutes, 7 minutes, 7 minutes, 11 minutes, 40 seconds. Very nice Matab. We see B. Dayton coming in there as well. 11 minutes. Very, very nice times there, guys. Really, really impressive. Uncle Facepound in the mix here. 12 minutes, 28 seconds. Very nice, very nice. T. Lust coming in here with Fusion. 20 minutes, 56 seconds. H11R coming in here. 21 minutes, 42 seconds from the time it was released. And then bringing up the caboose here once again. TooTallToby, 32 minutes and 8 seconds. But look, we got it done. We got it right. We got it right on the first try. Okay, slow is smooth and smooth is fast. And now that we know how to do it, we can always go back in and try again. At TooTallToby.com in the data and analytics, we capture all your runs. So if you do one of these runs, the first time, and then you think you can do it faster, you think you can do it better, well, you can try again, and then you can actually track yourself and see how you're doing, and you can see that you're getting faster over and over again. Yeah, and Lewis Mania saying he's going to do it using Creo. It's cool you can do it using different CAD systems. So we track all your runs, and we can actually track what you're using for each run, and that way you're able to actually see how you're improving or how you do, using one CAD system versus another. And of course, remember, if you ever get stuck, you can take a look here at TooTallToby.com. You can take a look at our tutorials. We do have a lot of tutorials here in a lot of different CAD systems, but you also have the ability to upload tutorials. These aren't just tutorials from me. A lot of these tutorials come from members of the community. So once you finish doing one of these challenges, you can go in here And in here, you can see that you can upload a speed modeling run, or you can upload a tutorial. So this is in data and analytics. So, we encourage all the members of the community to take a tutorial, post it on YouTube. You're not giving us the video. You're just posting it on YouTube and then sharing a link here to the YouTube video. So take a video, post it on YouTube, and then you too can become famous for your tutorials here on the TooTallToby CAD Challenges website. So, guys, I hope that you'll check it out. I hope you'll check out the practice models, and I hope you guys enjoyed that Onshape live solve using the coffee mug. It's a really fun model. And that's going to do it for today. Congratulations to our winners. Congratulations to Matab earning the first point. Congratulations to Mr. Misa earning the second point. The third one was just for fun, just for exhibition. Thank you so much to Victor K coming in with the $10 super chat saying, thank you, Toby, for the extra long live stream. It's absolutely my pleasure. Thank you all for the support. Thank you all for all the great questions. A question came in here at the end about plasticity and the unit system. I'm not sure what unit system it uses in the free version. I would say just hit them up. I know they have a Discord. I think they also have a Reddit, so you could probably ask them in there, and I'm sure somebody in there will be able to answer you. But I'm not sure what they use for their defaults. And Trax Joe 13 says, first time catching a live stream. Nice. Your channel has helped me really sharpen my skills. Thank you. Thank you, my friend. Thank you, thank you, thank you. That is awesome. I'll have a coffee. I'll have my coffee without a handle from now on. Nice, says Harry. Nice. And Bill Black says, thank you, Toby, for sharing the teacher. You're welcome, my friend. You're welcome. All right, guys. Thank you all so much. It's been a fun stream. A little bit of an extra live stream here. It was meters. There you go. It was meters. It's in SI. That's good to know. Very cool. Guys, it's been a lot of fun. Thank you so much for joining us. We'll be back again next week for another episode of Model Monday Live. Be sure to tune in throughout the week. We're going to be posting a lot of video content throughout the week this week, so be sure to tune in for that. If you're in the world of SolidWorks and you're looking to get some SolidWorks training from a SolidWorks expert, remember, you can sign up for our upcoming SolidWorks training class. The information for that is right here on the TooTallToby website. You just say access full library, and it's right here at the top. So it's training with a live instructor. It's tips and tricks on how to do stuff like what we did here today with that mug, except we're doing it in SolidWorks, not Onshape. But it's also advanced filleting tools, 3D curves, splines, helices, multi-body commands, advanced patterns, and lots more. So if you're interested in taking that class, we'd love to see you in there. It's 2 days. It's web-based, so you take it from the comfort of your own computer. But you do get to ask live questions to me throughout the training. I will be there with you, teaching you all my favorite tips and tricks from the world of SolidWorks advanced part design techniques. And with that, guys, have a great rest of your Monday. Try to stay warm out there. We got 6 more weeks of winter, according to our Pennsylvania meteorologist. So be on the lookout, stay warm, try to get some sun, and I will look forward to seeing all of you in the next TooTallToby live stream. See you, everybody.